Okay, this is a follow-up to my chemtrail webs falling from a blue sky in November and December 2015 in Texas. And this is just sort of what was happening November 1st. And now let me show you what these fibers, I collected about a tablespoon of these fibers, and I'm going to test them and give you the results. So let's look at a slideshow that I put together. Okay, this is the material that I collected November 1st. That was by far the heaviest spiderweb fall. And the spectrophotometry test shows that it is not spiderwebs. Okay, and I'm very disappointed. I was hoping to prove that it's 100 million baby spiders having a party, but the optical characteristics do not correspond to natural spider webs. Okay, now this is a local lab was nice enough to do some testing for me, so I have to say I not only collected all these samples, but I maintained custody of them 100% up through the testing itself. So there is no question as to whether or not these samples were the ones in question. Okay, we can see here the Chemwebs, this curve moves upward to the left. And in comparison to natural spider webs, which move downward to the left. Okay, let me explain this instrument a little bit. This bottom scale is the wavelength of light from very short ultraviolet up through infrared. And this is looking at the absorption of the fibers. I had to build a special holder, and this is more spider webs. These are very clean spider webs. And now this is all of the tests. So this is a spider web going down to the left. This is spider web. Now these are the 3 chemtrail samples, and they are actually going upward to the left, meaning that they absorb more ultraviolet compared to spider webs, which do not absorb UV very much. Because if you think about the strategy of a spider, they do not want their web to be highly visible to flying insects. Whereas you look at this material that I collected, it's bright white. It really looks like, white latex paint or white plaster or something. So we'll go ahead and show you the testing on this instrument. Now, I hope you're not eating because this is pretty gross. This is cobwebs, which I personally collected in January, and I tried to get the cleanest samples possible. And probably number C here is the best representation. There just wasn't much, and it's hard to collect this stuff. Now this one, B, is very dirty, and so C is the best one. D and E didn't have a whole lot, but I wanted to try to get as many clean web samples as I could. And this machine is designed to take a square glass container called a cuvette, and I had to actually create these, make these little black metal holders myself to do this test. And my thanks goes out to this lab who offered this equipment, and as a result, I'm not going to show anything that relates to the model number, which could be traced back to them. This is cobweb sample A, and you can see the spider here. The spider's alive in January, so this is a fairly fresh web, but there just wasn't much of it. Sample B, pretty gross, but that's a better thickness. Sample C, kind of embarrassing, and here's a picture of me putting sample C onto the metal cuvette holder. Sample D and sample E. It's really tough to wind that stuff on because it breaks and stuff. Doesn't want to go where you want. Okay, so that again is the natural spiderweb collection. So now we look at the machine output, and I didn't want to bother them, forcing them to print stuff out, so I just use a digital camera to take pictures of the screen. So you have to excuse the poor quality of some of these pictures. But this is with sort of a calibration. This is with no sample. It has the little metal holder, but there's no spider web on it. So this is actually 0. So you actually have to, I didn't want to bother them to, zero this out. So we just have to ignore, there's a step function here and a step function there. You have to ignore that. And here, I forgot to, this is sample A, and I forgot to take a picture of it. So this is sample B, and you can see they're going downhill as you go to the left. Natural web C. This is like the best one because it shows this curve going down, and ignore the step. That's where the instrument is shifting ranges. And then this is your super short UV, which is a whole nother instrument range. But you can see a spider web does not absorb UV very well. A lot of insects actually navigate by looking at things in UV, so I presume that it's a good thing that it's less visible to the spider. But okay, natural web D, and that's the black one here. And the D one didn't have much web on it, so the absorption is much lower. So we don't care about how high these curves are, we care about the shape of them, that they're all going down to the left. Natural web E, and that's this green one here. There was almost no web on there, so I probably should have not tested that one. There's just not a whole lot of data right there. Okay, now back to my samples, which I personally collected and maintained custody throughout the whole process. And this Chemweb number 1 here, I picked it up with my bare fingers, because I was just going around just stunned about all this junk. So that's one reason I didn't want to send it off to a lab, because it's contaminated with sweat, sodium and chloride. The other thing is, if you lose custody, in my opinion, the lab results are meaningless. So here's me wrapping those fibers. I use tweezers onto the metal cuvette, and here is the test result shown in the black line there. And again, it's going up. It's going up to the left, and you just got to ignore this jump here and this jump here. That's kind of hard to not pay attention to. Chemweb November 22nd, I'm wrapping it on there, and I kind of screwed up because I didn't really wrap it tight enough, because I can see a hole right there, so that was a screw up there. Now this one is really flat. In fact, it goes down a little bit right here, but it's not going down as much as the spiderweb samples. And Chemweb 6. Now this one I worked a little harder to cover up the holes that might be showing. And now this one we do see it going uphill to the left, absorbing more ultraviolet than it does infrared here. So here's a composite of all of the testing. And so these are the Chemwebs, and this is the best of the spiderweb sample. And I wanted to find different species like black widow and stuff, but I just wasn't able to this time of year. And this is a blow up of the Chemweb area. So we can definitely see it absorbing more UV. In fact, there's a peak here right at about UVC, right about 250. This is the germicidal UV here, and we can see there's a peak there. So from infrared through visible light to UV, it goes uphill. And then once it hits the deadly UV, and there's none of this reaching the Earth's surface, thank God, and it actually has less absorption here. So this looks like it's tuned to absorb UVC, in my opinion. This is the natural spider webs blown up. You can see they look to me to be just natural, sort of random. And there's our sample C, which is the best one. Again, the blow up of the Chemwebs. Okay, so that's the report. Apparently this stuff is not natural. It's actually it looks like some kind of military test program, if you ask me. And I wanted to make a summary statement that since these fibers absorb UV so well, that you could have protein molecules embedded in there like DNA and RNA, and the fibers would actually protect the protein as it's falling through the sunny afternoon. In other words, it's the first component to a covert bioweapon, a disease delivery system. And that's really scary and upsetting. But these test results kind of point in that direction. And the other thing I wanted to mention was, as a final statement, the Chemwebs, they do not match the optical properties of natural spider webs. So the question, are they natural spider webs, I think has been answered here, that they have a different spectral response than natural spider webs. Natural spider web, Chemwebs. And I'm very sad at this result. I really wanted to find that it's just 100 million baby spiders having a party. So I am very upset and sad at this result. And I encourage other people to do real testing. This is a calibrated scientific instrument, and there are hundreds of people out there with access to instruments like this who can do testing. And why am I the only one that's done this, who's not in a Black Ops program? Leave a comment, and the shills are going to just really have a heartburn over this. Hey, thanks a lot.